Welcome everybody once again. So we are in our third module. This is our 14th class, and in this class we are going to see problems on hydraulic gradient line and total energy line. HGL means hydraulic gradient line and TEL means total energy line. And we have already seen hydraulic gradient line is the line joining the hydraulic gradients. So line joining the hydraulic gradients. Hydraulic gradient means it is the summation of pressure head and datum head, that is P by rho G plus Z, that is hydraulic gradient. Hydraulic gradient line means the line joining the hydraulic gradient. P by rho G plus Z is hydraulic gradient line. TEL means total energy line, that is the line joining the total energy, where total energy is equal to pressure head plus velocity head V square by 2G plus Z. Okay, this is total energy and this is hydraulic gradient. Now we will see a few problems related to this. So the first problem is, determine the rate of flow of water. So the flowing liquid is water. We need to find the rate of flow. That means we need to find what is Q, what is the discharge. So determine the rate of flow of water through a pipe of diameter 20 centimeter and length 50 centimeter. So we have a pipe. There is a pipe. Okay. There is a pipe and this pipe is of diameter 20 centimeter. So 20 centimeter, that is equal to 0.2 meter, and the length of this pipe is 50 meter. Okay, length of the pipe is 50. It is not 50 centimeter, this is 50 meter. Length of the pipe is 50 meter. When one end of the pipe is connected to a tank and other end of the pipe is open to the atmosphere. So one end of the pipe is connected to a tank and the other end of the pipe is connected to the atmosphere. So we have a tank. So this is the tank, right? So one end of the pipe is connected to the tank and other end is free to the atmosphere. Open to the atmosphere. The pipe is horizontal and the height of water in the tank is 4 meter. So the pipe is horizontal and the height of water in the tank is 4 meter means, see, from this level, from this center line of the pipe, the height of the water in the tank is 4 meter. That is the meaning of that. Okay, so this distance is 4 meter. The height of water in the tank is 4 meter. 4 meter above the center of the pipe. Okay, so it is given the height of water in the tank is 4 meter above the center of the pipe. So from the center of the pipe, the height of water is 4 meter. Consider all minor losses and take coefficient of friction F is equal to 0.009 in the formula. HF is equal to 4FLV square by D into 2G. So this formula is nothing but Darcy-Weisbach formula for major energy loss, that is energy loss due to friction. Also, we need to draw the hydraulic gradient line HGL and TEL. So we need to find what is the discharge, we need to find the hydraulic gradient line and we need to draw the total energy line. So I will remove this because here only we are going to draw the lines. Okay. Now we will write the given data. So the diameter of the pipe is given, D is given as 20 centimeter, that is equal to 0.2 meter. Now the length of the pipe L is equal to 50 meter. Height of water in the tank above the center line of the pipe is taken as h, that is equal to 4 meter. Coefficient of friction is given as 0.009. 0.009. We have to use this in the formula. HF is equal to 4FL V square by 2GD or D into 2G. Now, we will apply. So, these are the things that is given, right? First of all, we need to find, our aim is to find the discharge. So, in order to find the discharge, we need to find what is, we know discharge is equal to area into velocity. Right? So, we need to find what is the velocity first. So, in order to find the velocity, we can use this formula. So, we know F, we know L, we don't know velocity, we do not know the total hydraulic loss. So, what we can do is, we can apply the Bernoulli's equation. We will apply the Bernoulli's equation at two sections. So, we will take our section 1, the first section, at the top surface of water in the tank. And the second section can be taken at the outlet of the tank. So, when we consider these two sections, we apply the Bernoulli's equation at the top water surface of the tank and at the outlet of the pipe. So, taking the point 1 on the top and point 2 at the outlet of the pipe, what we get is, apply Bernoulli's equation. So, apply Bernoulli's equation, we get P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus all losses. So, here we have major losses and minor losses. So, all losses means it includes major loss as well as minor losses. Okay, all losses means it is major and minor losses. Okay. Now, we will consider the datum line along the center line of the pipe. We will consider this as the datum line. The center line of the pipe is considered as the datum line, so that we get this P1 by rho g. Pressure at this point, P1 by rho g will be equal to 0. So, at this point, pressure is equal to 0, pressure head is equal to 0. Now, the velocity head also will be equal to 0 plus the datum head is, it is 4 meter above the datum. So, 4 meter. See, why pressure and velocity head is equal to 0? Here it is constant. Okay, the level of water is maintained constant. Now, this is equal to P2 by rho g. So, pressure will be equal to 0 plus V2 square by 2g. Here there is flow. So, there is velocity. So, V2 square by 2g plus Z2. Section 2 is lying on the datum line. So, it is 0 plus all losses. So, what are the losses? So, there is an entrance, right? Entrance of the pipe. So, it is HI minor loss plus HE the major loss. HE major loss is taken as F. HI is inlet, loss due to the inlet of water through the pipe. Due to this inlet, we will have the loss HI. HI is loss due to inlet, head loss, loss of head due to inlet, and loss of head due to friction. That is HF. That is the major loss. So what we get is 4 equal to V square by 2G plus HI plus HF. Now, what will be the velocity in pipe? So let us take the velocity in the pipe as V. So this is V2 square. Let it be V2, no issues. Now what is HI? So this is equation number 1. So HI, that is loss due to the inlet. The formula is 0.5 V square by 2G. So substituting, we get 0.5 into loss in the inlet. This velocity is considered as V2. Okay. This is due to the inlet of the pipe. So this velocity is nothing but V2. So 0.5 V2 square by 2 into 9.81 or 2 into G by 2G. Now we will see what is HF. HF is given as 4FLV square by 2GD. So here also the V is taken as V2. Here also V is taken as V2. Because at section 1 velocity is equal to 0, there is only one velocity, that we will take it as V2. Only velocity at section 2. So that will be considered as V. So V2 is equal to V. Now we will substitute in this formula. So equation number 1 implies 4 is equal to V square by 2G plus what is HI? 0.5 V square by 2G plus HF is 4 into F, coefficient of friction is given as 0.009. L, length of the pipe is given as 50 into V square by 2 into G into D. D is given as, the diameter of the pipe is 20 centimeters, so it is 0.2. So for G we can substitute 9.81. G is equal to 9.81. So the only unknown is V. So from which we get the velocity V is equal to 2.734 meter per second. Now once velocity is known, we can calculate the discharge. We know discharge is equal to area of the pipe into velocity of the pipe. So area of the pipe is pi d square by 4 into velocity. So area d is 0.2 square divided by 4 into velocity is 2.734 meter per second. From which we get Q is equal to 0.08589 meter cube per second. So converting it into liters, you divide it by 1000, you get 85. Sorry, multiply it by 1000, we get 85.89 liters per second. So this is the discharge. So first part is over. Finding the discharge rate of flow is over. Now we need to draw the hydraulic gradient line and total energy line. So how will we draw this? Okay. So drawing the hydraulic gradient line. Hydraulic gradient line, we know it is nothing but hydraulic gradient line is equal to the line joining the summation of pressure head plus datum head. Right? Now, first of all, we will try to draw the total energy line. After that, we will draw the hydraulic gradient line. So, we will consider 3 points A, B and C on the free surface of water in the tank. Okay, we will consider 3 points A, B and C. A on the free surface of water in the tank, B at the inlet of the pipe and C at the outlet of the pipe. So, we will consider A, B, C. Now, this point A is considered at the free surface of water. Point B is considered at the inlet of the pipe. Point C is considered at the outlet of the pipe. This is point C. Okay, outlet of the pipe, point C. Now, let us find the total energy through these points, that is at A, at B and at C. So, total energy at A will be equal to P by rho G plus V square by 2G plus Z equal to 0 plus 0 plus 4. Okay, at here P by rho G is equal to 0, P is equal to 0 and velocity is equal to 0 at the free surface of water. Z is 4. So, first of all, we are considering the total energy at A. So, first we are going to find the total energy line. So, total energy at A. At A will be equal to P by rho G plus V square by 2G plus Z is equal to 0 plus 0 plus 4, that is equal to 4 meter. Now we will consider the total energy at B. What is the total energy at B? At B we have an inlet of the pipe, right? We have the inlet of the pipe. So at B, because of this inlet, there will be a minor loss. So at B, the total energy will be equal to total energy at A minus the minor loss. That is total energy at A minus HI. That is loss due to the inlet. So we have already determined the loss due to inlet as 0.5 V square by 2G. So what we get is, we will find the total energy at B is equal to total energy at A minus HI, that is loss due to the inlet. That is 4 minus loss due to inlet is 0.5 V square by 2G. 0.5 V square by 2G. V we have already calculated as 2.734. So, substituting the value, substituting V equal to 2.734 and G is equal to 9.81, we get the total energy at B as 3.81 meter. Now, we will determine the total energy at C. So, total energy at C is equal to P by rho G at C. So, that will be equal to 0 plus V square by 2G at C. So, here V is not equal to 0. V square is V is equal to V2. Plus Z is equal to 0 because datum line is along the center line of the pipe. So, what we get is total energy at C is equal to P by rho G at C plus V square by 2G at C plus Z at C. So we get P by rho G is 0, V square by 2G, V is nothing but 2.734. 2.734 square by 2 into 9.81 plus Z is 0 because the datum line is along the center line. C lies on the datum line. So it is 0. So we get the total energy at C as 0.38 meter. Okay, so 4, 3.81 and 0.38. Therefore, the total energy line will coincide with the free surface of water in the tank. Okay. So, the total energy line, say repeat, the total energy line will coincide with the free surface of water in the tank. At A, it is 4 meter. So, total energy will coincide at the free water surface of the tank. At the inlet of the pipe, it will decrease by HI. This is HI, right? It will decrease by HI. So, HI is equal to 0.19 meter. If you calculate HI, you will get 0.19 meter. So, it will decrease by 0.19 meter from the free surface. And at outlet of pipe, total energy is 0.38. Hence, we can show in the figure as, we will draw the total energy line. So, we can give some green color. So, this point D represents the total energy at A. Okay, that is 4 meter. From the datum line, 4 meter. Total energy at A. Now, we will mark some point E here. So, this point E represents the total energy at inlet of the pipe. Total energy at inlet of the pipe. Okay. That is 3.81. Total energy at the inlet of the pipe. Now we will mark a point F. So this is point F. So D, E, F. This point F, that is this is CF is equal to 0.38. Okay, represents the total energy at the outlet of the pipe. I repeat, D represents total energy at the free surface of water. E represents the total energy at the inlet of the pipe. And F represents the total energy at the outlet of the pipe. So now we will join D and E. Join D and E. Join D to E and E to F. Okay, join D to E and from E to F. Now this DEF represents the total energy line. So this line is called total energy line, DEF. So at D it is 4 meter. At E, DE is equal to 3.81 meter. At F, CF is equal to 0.38 meter. That is the meaning of that. Okay. So how will we mark this? This dB. So first of all we will mark this. This is 0.38 meter. So I will mark here, right? Or here we will mark. So this is 4 meter and this is 3.81 meter. 3.81 meter. Okay. 4 meter, 3.81 meter and 0.38 meter. This is how you have to mark the total energy line. Now we will try to draw the hydraulic gradient line. We know hydraulic gradient line is equal to pressure head plus datum head. So next is hydraulic gradient line. Okay. So hydraulic gradient at A will be equal to P by rho G plus Z. P by rho G plus Z is equal to 0 plus 4 is equal to 4 meter. Next, hydraulic gradient at B is equal to this total energy at B minus the velocity gradient, right? Velocity gradient is V square by 2G. So what is the velocity gradient here? Now, hydraulic gradient at C will be equal to P by rho G at C plus ZC. So that will be equal to 0. Now at B, it is minus V square, total energy at B minus V square by 2G. So 3.81 minus V square is 2.73. Okay, V square by 2G is 0.38. 0.38. So it is, let me calculate, 3.81 minus 0.38, we get 3.43 meter. Now, so at C, the hydraulic gradient is 0. At B, that is at the inlet, the hydraulic gradient is 3.43 meter. At A, the hydraulic gradient is 4 meter. So what we get is, let us draw. At C, the hydraulic gradient is 0. At the inlet, the hydraulic gradient is 3.43. So somewhere here. So let us take this point as F and G, okay? G. Let us take this point as G. And at the free surface, at A, the hydraulic gradient is 4. So this line is the hydraulic gradient line. So hope you understood this problem. We will see two more problems related to this hydraulic gradient line and the total energy line in the next class. Thank you.